Illustration number 11. A circular turntable rotates in the horizontal plane with the angular speed of 20 rotations per minute about a vertical axis which is passing through the center. A man of 60 kg mass is standing on the edge of this table, and here the event is given in which the man goes from edge to center. Then what would be the angular speed of the turntable? And here I am starting the analysis as determining some properties. So first of all, mass of a man, which I am denoting as small m, that is equals to 60 kilogram. The other mass of turntable is also given. Therefore, mass of a turntable is equal to capital M 200 kg. And so, one more thing which you should have noticed over here, that it is a uniform disk, means the mass is a uniform disk, and so the torque acting on a system, and here the torque is not internal or external, it is resultant torque acting on the turntable is 0, and when the torque is 0, one of the quantity is remaining conserved, and the quantity is angular momentum, so that is remaining constant. So with the help of this, now I can study about the initial angular momentum, and here now I am combining the case of table as well as man. So initial angular momentum of table and man, that is equal to final angular momentum. Now the initial angular momentum is given by, so first of all, initial angular momentum of table will be, that is mr square by 2 plus the initial momentum or angular momentum of man. So it is with mass small m into r square only into omega 1, that is equals to the final angular momentum will be that of only table. So mr square by 2 omega 2. Simplifying this case, so r square on the both the sides will be cancelled out. Therefore, m by 2 plus small m omega 1 is equal to m by 2 omega 2. Now, we have the known values of capital M, small m as well as the initial angular velocity, and therefore the value of capital M is 200. So 200 divided by 2, so that is 100 plus mass of man is 60 kg, omega 1 20 rotations per minute. Here also 200 by 2, then it is 100 omega 2. So it is 160 into 20 divided by 100, that is equals to omega 2. So 0 zeros are cancelled out from numerator and denominator. So the angular velocity at the present is given by 32 rotations per minute. So here you have observed that when a man is in the motion towards the edge from the center, then angular velocity of the particle or of the turntable is increasing. And so with this, our illustration number 11 is over. Now let's start illustration number 12. Starting the illustration number 12, a child of mass m is sitting on the board of the merry-go-round, which is rotating about an axis passing through its center and that is perpendicular to its plane, which is 1 meter away from the axis. And you can clearly see from the origin, child is on the board in which the child is sitting is 1 meter away from the center. So, with what angular speed the merry-go-round rotated so that the child is on the verge of sliding of the board of it. So, we have to find out the angular velocity. Here the force which is acting in the perpendicular distance of child, that is r, and it is nothing but a normal reaction. And this mv square over r is very well known centrifugal force. Now when the frictional force which is given according to the static frictional constant means Fs is equals to mu r changes to mv square over r, then the child is on the verge of the sliding on the board of merry-go-round. That means these two values should be same, and hence this is the condition. So mu r is equals to mv square over r, that is equals to, now instead of r you can see which kind of force I can write, that is normal reaction. It is gravitational force mg. So instead of r now I am writing mg. And so m is cancelled from both the sides. So v square over r is equals to mu g. Now the value of v is r omega. So v square is equals to r square omega square. And therefore if I make omega square as an object, so omega square is equals to mu g over r, because this r is cancelled in the numerator. And so the magnitude of angular velocity, that means omega, is under root mu g over r, equal to under root of mu is 0.25, g is having the value 10 and the r is having the value 1. So the value of angular velocity is 0.5 radian per second. Now let's start illustration number 13, which is the last illustration of this chapter. Illustration number 13. A string is wound around a disc of radius r, as you can clearly see from the figure, and it is having mass capital M. And at the free end of the string of a body of mass M is suspended. And so it is experiencing the force or the gravitational force mg. So according to the equation of linear motion, we can clearly say that the value of force in terms of acceleration is equals to the gravitational force minus tension kind of force. Here the T is represent the tension of the string, and so the equation for tension in the string, therefore T is equals to M into G minus A. So this is the first equation in this illustration. Now if we talk in terms of the torque which is applying on the disc, so this torque is given by the equation tau is equals to, in that I into alpha, but here we will consider the another equation that was in terms of R cross F. Here I am putting instead of R the radius of a disc and the value of force as capital T, means a tension kind of force, and so I can compare this equation with I alpha, and so the acceleration I can make now an object. So alpha is equals to RT divided by I, which is equals to R into M into G minus A divided by the value of I for a disc is given by mr square divided by 2. So here this 1r will be cancelled out, and so the value of alpha will be twice m over capital M into R into G minus A. But here the value of simple acceleration is given or is related with the angular acceleration by this equation capital R into alpha, and so by substituting this value means twice mg over mr minus twice mr alpha divided by m into r, and so here r is cancelled out, and after simplifying this I can get that alpha plus twice small m alpha upon capital M is equals to twice mg over mr, and now I can take common this alpha from left hand side. Therefore, the value of angular acceleration will be, after the simplification, mg over capital R into small m plus capital M by 2. That is the final equation, and hence with this all the illustration are completed. Now let's see the last theory of this chapter.